This is AP Physics, Chapter 28, second assignment. Problem number 11. You're given the EMF of the battery, the currents as different switches are open and closed, and you have the three resistor values you want to find. Well, if you have three unknowns, you're going to have to set up a system of three equations. So we're going to redraw the circuit by closing it to each of the given switches. So the first current value that's given is when the switch is open. When the switch is open, effectively those central wires in the middle of the circuit are not there because they're not connected to anything. So then when we redraw what's left, you have R1, R2, and R3 in series. And you can use that with Ohm's law to be able to set up the first equation. When you close the switch to A, then what you have is a little parallel between the two R2s. You can just slide the upper R2 around the corner without passing a junction. So you have R1 followed by the two R2s in parallel, followed by R3. So finding the equivalent resistance of that, effectively you have the parallel being an R2 over 2. And then in series adding R1 and R3 to that, and then setting up the second equation with Ohm's law. When you close the switch to B, then the central vertical R2 is essentially gone because it's not connected. And then you have an interesting parallel where R3 is parallel to just a wire. Well, that wire has basically no resistance, okay, as opposed to R3 where there is resistance, and so that acts as a short circuit and eliminates any current flow through R3. So then effectively what is left is R1 and R2 in series, and then you can use Ohm's law to be able to set up that third equation. Once you have those three equations shown over on the right side, it's basically a system of equations. Do substitutions, solve down for your R1, R2, and R3 values. In problem number 13, you have essentially what is a series circuit. The 5 ohm resistor in the middle makes it a series circuit. So then you have a little parallel with the 12 and 6 that you can combine with the inverse equation to get a 4. A little parallel with the 4 and the 8, which you can combine to get a 2.67, and then those three resistors, the 4, the 5, and the 2.67 in series to combine to get the equivalent resistance of 11.67 ohms. From there, you want to find the currents in each. It's a matter of breaking down the circuit once you find the total current, and then follow the math that is there on the bottom of the page to be able to calculate each of the individual currents. So in problem number 14, you have the circuit shown, and you're looking at the equivalent resistance between points A and B, which are those two dots on the left side of the diagram. Okay, if the switch is open, then effectively on the vertical parts, you have a 90 and a 10 in series on both sides. So either branch you go through 100 ohms of resistance. When you close that switch in the middle, what happens is you turn that into a series of two parallels. Each of the parallel would have a 90 ohm resistor and a 10 ohm resistor. So then prior to when it was open, you had to go through 100 ohms. When it's closed in parallel, effectively charges could go through the 10 on the left, go through the middle branch and through the other 10 and only go through a resistance of 20, or go through the other branch of a 90 and a 90. Basically what's happening is you're adding another path, and adding another path you will decrease the equivalent resistance. Now in part B, you're assuming that the equivalent resistance is decreased by 50%, and you want to calculate the value of the unknown resistance R. To be able to do that, set up an equation for the open and set up an equation for the closed. When it's open, you have 100 and 100 in parallel, and it's the inverse equation. So our parallel is 50 ohms. When it's closed, you have to do each of the 90 and 10s that are in parallel. So the 90 and 10 in parallel give 1 over 90 and 1 over 10, which will give 1 over 90 plus 9 over 90, or 10 over 90, inverted 90 over 10, okay, which is 9 ohms. So then you have two 9 ohms in series with R for an equivalent resistance of R plus 18. Use then that 50% to set up an equation between the open and closed and solve down for your R value to get 14 ohms. So problem number 15. You've got two unknown resistors that are placed in series to give a combination of 690 ohms and in parallel to give a combination of 150 ohms. So we can set up the series equation and the parallel inverse equation. So we've got two equations and two unknowns. Take the series equation, solve it down for R1, substitute it into the inverse equation, do a lot of algebra, and solve the equation down. On number 17, effectively you have a circuit with a little parallel of the 3 and 1, which you can use the inverse equation to solve for the resistance of 0.75, and then the 2 and the 0.75 in series, also with the 4. So you get an equivalent resistance of 6.75 ohms. Use that to find the total current using Ohm's law. Okay, and then go through and calculate the power on each resistor by whichever equation you know enough to use.